molecules and structures, and chemical bonds. How did it all happen? Well, before the beginning of times, there was nothing. Then there was a Big Bang. And this brought about the rules necessary to build the universe and particles as building material, in particular neutrons, protons, and electrons. A small portion of these particles came together to create chemically stable atoms. Atoms are a bit like Russian dolls, a core made of a positively charged nucleus inside successive shells carrying electrons. The smallest shell can carry 2 electrons, and the few next ones 8. Atoms with full shells and no global charge, such as helium or neon, are chemically inert. They are an exception. Indeed, most particles gave rise to chemically unstable atoms, which, to obey the Big Bang rules, had to combine to create molecules and chemistry. Here is the smallest imperfect atom of them all, hydrogen, with only 1 electron. If only it could have 2. And here's another one, oxygen, with 6 electrons. If only it could have 8. Well, if one oxygen can somehow be bonded to 2 hydrogens and their electrons shared, we get a win-win. And we also get water, H2O. This pairing of electrons is called a covalent bond, and it is very common throughout the universe. H2O can be written like this, with each dot being an outer shell electron, or like this, with every stick being a covalent bond. Such bonds can be single or double, like in the oxygen we breathe, or even triple, like in the nitrogen we breathe as well. Covalent bonds are the skeletons of all large molecules. Energy is often needed to create them, and this is what heat does to pizza. In addition, they can be very strong. Diamonds, as James Bond knows, are forever, because they are made of myriads of covalent bonds. But there is something funny about the water molecule. Its electrons are clustered on the oxygen side, and this creates an uneven distribution of electrical charges. Negative on the oxygen side and positive on the hydrogen sides. So when 2 water molecules meet, they can connect through opposite sides. This bond, so important in biology as we'll see later, is called the hydrogen bond. Finally, some atoms are so close to the highly desirable 8-electron shell state that they are willing to give away or adopt electrons, if only another atom would agree. Sodium, for example, has 9 electrons, while chlorine has 7. If the two meet, it's instant and violent love. Sodium donates its electron and becomes a positively charged ion, and chlorine happily accepts it and becomes a negatively charged ion. The two become very strongly attracted to each other via a bond called the ionic bond. These 3 types of bonds: covalent bonds that are like bolts and nuts, hydrogen bonds that behave collectively like Velcro, and ionic bonds that act like very strong magnets, are the main forces that dictate the composition and the shape of all molecules in the universe, including the most amazing ones of all, living macromolecules.